it's easy that we have AI now, and even in Colab, that is the platform provided by Google, we can see that there is an option once we open this Jupyter notebook, we can see that there is something called start coding or generate with AI. And if we click with generate with AI, and we're trying to learn numpy, and learning numpy is easier now. Just say, teach me numpy. And as soon as I do enter, now it will give me some examples. And we can see here, it is trying to teach me numpy. So here we are importing numpy as np, and we are creating an array. And this is array that contains, let me zoom this a little bit. Or let me zoom this again. So here we have this numpy module imported by import. And this is the shortened form for that module, for that numpy. And we can say np dot array. And here inside this curly brackets, not exactly curly brackets, within the parentheses, and we have these big brackets, and we're providing the numbers. So this is the 1D array. Then we also have the 2D arrays, and then we do np.array. This is the same thing, but now we have two big brackets here. One first big brackets outside, then we have numbers within the big bracket, and then again another list of numbers in the second big brackets. And we can run this, and Colab has given this example, and what we can see here, oh, there's a lot of other examples as well. So if we dive here, we can also see, let's go through the examples. So here, so let me copy this for now. And okay, it has given lots and lots of examples. So let me copy this first. Let me copy this one for now. And let me copy this for now. So this is the first arrays, and you can also see the creation of zero arrays we do by np.zeros. We can also print them, and here we have np.ones for creating in different arrays, and there is a arrays full of only one number. And what you can see now is here we have the arrays with 7, that is the one, that's for the 7. Then we have the range, np.arrange 10, and this is giving us an array from 0 to 9. Then we have the line space, where we can see that there is a space like that, a line space by this line, some kind of space between the numbers here. So this text that I provided is giving me a very long list of the thing. So what I'm going to do now is I think I should delete this, and for deleting this is, I think, how do we delete this? Okay, let me see. Oh, here it is. So I can do the code, and this time again I'm going to do the generate, and let me say numpy examples of creating arrays. Now you can see is it has already again given some arrays. So there is for the first example of creating one-dimensional array, and we have the two-dimensional array, and then we have the arrays that contain 0 values and arrays containing 1 values, and arrays that will just contain the single number. And this is the size here, 227. 22 is a number of rows and number of columns, and the number of 7 is the value that will be filled in all the positions. Then we have the arrays with random values, and let's run this, and this is what we get. So here we have random numbers. So let us do some other examples as well. So numpy examples of doing maths. So let's do, oh, it's not the AI here. We have to click on the generate. Let's say numpy examples of doing some math. Let's do this. And what we get here is a first array with 3 values, and second arrays with values 4, 5, 6. And we can do some addition, subtraction, division. We can even do the dot product there. We can do matrix multiplication, transposing is there, and sum of elements are there. We can sum all the elements. And we can also do some statics, like finding the mean, finding the standard deviations, and finding the maximum values and minimum values. So these are some examples. So let's run this again, and what you see is the long list of numbers. So let's try to understand what's the difference between the usual arrays in Python versus the arrays by numpy. So what's the difference between usual arrays in Python versus the arrays, the special arrays by numpy? So we have the numpys as imported as np again, and we can print them, and the elements by dot append. This will add the 6 here. We can print the arrays by dot remove. We can remove the elements from that Python array, and this is the numpy arrays. And then we have the numpy arrays. So it is not giving me the usual Python arrays. I'm not seeing. Oh, here it is. This one is a. Oh yes, we can understand this one. This one is the normal arrays. That's the usual arrays, and this one is the Python array. The functions used are somewhat similar, but here we are doing np.append, and then providing our array here, and then adding the numbers. The thing will be the same here, just how we utilize it. So let us say, for instance, let's say numpy array versus usual Python array memory size. Let's do that one. And if we see now, this one is creating the Python list for number of values, and then eventually we're getting the size of that list, and then we're creating the same Python list as a numpy array. And what we do, we get is the size, and what you can see is the Python list size is somewhat bigger than the numpy array size. And I'm curious why this is happening like that. So let's say why numpy array size is small, and this will kind of answer me in that format by commenting every line. So numpy arrays are not more efficient in terms of memory usage because they store data in a contiguous block of memory. This is in contrast to Python, which store data in different locations in memory. This difference in memory layout leads to significant performance gains when working with numpy arrays, especially for large datasets. Additionally, numpy arrays use a fixed data type following elements, which further reduces memory usage. So numpy arrays uses a fixed data type elements. So it has the contiguous block of memory. So they are making everything the same data type. They're also doing contiguous block of memory. And let's do and next example. So there is also a shortcut that is Control plus MB, depending on your computer. It might also open up other things. So I would prefer just clicking here for now. And let's ask, for instance, why are arrays that important? I want to know why the arrays are that much important. And it says, again, gives me the example. NumPy arrays are more efficient in terms of memory usage because they store data in context of memory. So it is the giving the same answers, I would say, in general. So it is not providing any new text. It is not providing any new text. Let's see. Let's say arrays example where we change the type of arrays. Let's see the example of. So we are creating a 1D array again here, and then we're receiving it at 2.3 by dot receive. We can also receive it as 3D array. So basically, we're doing dot receive function to change the shape of the arrays. Well, this was the start example. So there are multiple possibilities to learn Python. We do not need to go and search the blocks. We do not need to find anything. If we know what we're doing, we can ask the questions multiple times and then get some result and try to run them. For instance, what we're doing now is we are just asking that AI to give or provide us an example, and it is giving us the example in a very quickly, in a very quick manner, and that is very helpful. So we will try to learn more things. We will try to learn further. Thank you for watching.